Welcome back, Patriots. This is Mr. Love, aka the Math Patriot, bringing you another fun and exciting lesson in the world of high school geometry. Hope you guys are all doing well. We're starting off a new unit today, covering area and perimeter. Hey, you guys covered this stuff a lot back in middle school. I hope that nothing we're covering today is new. We're going to go a little bit further than you did back in your middle school days. We're going to throw in a little bit of trigonometry and that sort of stuff, just because this is high school now. So, before we move on, I hope I fixed some of those strobing issues. I know some people were complaining about that. I upgraded. I went to Walmart and bought some poster board. Look at this. I seriously have poster board behind me. So, hey, I spent $6, upgraded, and I also got a camera that's off the tablet, so I can actually, have my tablet going on here now. So hopefully my handwriting will improve as well. Anyway, let's get this going. All right. So first off, you'll notice if you have in the note sheet that I provided, I've got at the very top of that a summary of all of the different shapes, all their area formulas and so forth. Now, the way this is going to work as I'm going through the lesson, I'm going to go ahead and show you the reasoning and the logic behind some of these formulas, and then we'll just jump into the examples. Now, there's nowhere to write any of this because you've got that summary right there on top. So that's what we're going to do with all this. First off, parallelograms. One of our most basic shapes to find the area of. First off, the base of a parallelogram is going to be any of these sides. Doesn't matter which of the sides, you could choose any of them. The height of the parallelogram is always going to be the perpendicular distance to one of the two parallel bases. So since I chose this bottom one as the base, then this guy right here is going to be the height. Now, in theory, I could have done it the other way around. I could have made this the base, and then I'm not going to do this very well, but the height would be this guy as long as it's at a right angle. Okay, either one works. My point is the base does not have to be on bottom. Remember, we covered that a lot back in our parallelograms unit. The base is not always the bottom. The base is defined. In this case, base is always going to be one of our two parallel sides. For parallelogram, that can be any of those. So area of a parallelogram is going to be base times height. So that, notice what essentially goes on here. We have our full base. If I was to cut this and cut this right along the height that hits right here at the one of the vertices, then take that entire triangle, take this triangle and move him to the other side. Notice that I've made a rectangle. So this base times height is essentially the same thing as a modified area equals length times width that you used to do back in middle school and even elementary school. So area is base times height. I'm going to use this for all parallelograms, including squares and rectangles. So you will never see this guy anywhere in my vocabulary, anywhere in my formula sheets. That was the elementary school. That was back when we were doing milk. It's time to grow up and do some meat. And so now we're doing length. I'm sorry, not doing length and width. We're doing base times height. All right, let's go ahead and find the perimeter and the area of parallelogram RSTU. Let's do that perimeter first. Remember, perimeter, if you don't remember, distance around the outside of a shape, all of the edges. So each side is going to be the same, or each opposite side is congruent. So here, UT is also going to be 32 inches because it's going to match the one above it. Going to match RS. Also, ST is going to be 20 inches because it's going to match RU. And therefore, my perimeter is just going to be 32 plus 32 plus 20 plus 20. Let's see, that gives me 64, 84. So my perimeter is 104 inches. All right, now let's do our area. Area is just going to be base times height. My base is going to be 32 times my height, which is this distance here. I don't have that distance. I'm going to have to find it. Now, we do have this right triangle, so I can go in and say, and this is my h value, 12 squared plus h squared equals 20 squared. So that gives me 144 plus h squared equals 400. Then we're going to subtract that out. 400 minus 144 is 256. All right, sorry about that. I had to rearrange while I got my calculator up. So square root of 256 is 16. So my height is 16. I'm going to take that and pull it into my formula here. 32 times 16. So 32 times 16. Area is 512. And let's make sure we got our units there, inches squared. All right. Nothing major there. All right, let's go ahead and find the perimeter and area of this parallelogram. We are going to, first off, need to find the lengths of our different sides here. We notice it's a rhombus because all four sides are marked as congruent. Therefore, this one is also 24. And I want to pay attention to this particular triangle that's listed here. Let's see, this angle here is also going to be 60 degrees, and it looks like I now have a 30, 60, 90 degree triangle there. So I'm going to draw this the same way that I'm used to, and I know that on my 30, 60, 90 triangle, if this side was S, then the hypotenuse is 2S, and then the medium side, the long leg, is S times the square root of 3. So when I translate in here, it looks like my hypotenuse is 24. That's my 2S. So my short side is half of that, which is 12. And then my long side, my long leg, is 12 times the square root of 3. Okay, let's see what we can do with that. Perimeter. Well, it looks like actually perimeter is just going to be 24 times 4, because I'm adding up all four of those, all four sides, and they are the same. 24 times 4 is 512. Whoa, I was off by a line. That's 96 inches. Now, for my area is going to be base times height. Base is 24 inches. That's my one across the bottom. Base is there. My height is 12 square root 3. Now, since the directions tell me to round to the nearest tenth if necessary, then I can go in here and just type in the calculator 24 times 12 square root of 3. And my area is, don't need to highlight there, 498.8 inches squared. Okay, moving on to our next shape, the triangle. Now, triangle still has a base and it still has a height. We've covered this back in our first unit. And again, I harped on that. Base is not the thing it's sitting on. The base is one of the sides, any of the sides, and the height is the altitude, which is perpendicular to whichever side I am using as the base. So this particular drawing, this diagram was done specifically to drive that fact home that it doesn't have to be the one that it's sitting on. Any of the sides can be the base, and the height is just going to be perpendicular to it, the altitude. The area of the triangle is 1/2 base times height. Okay, think about what's going on there. If I had a rectangle, the area of that rectangle would be base times height. Now, if I was to cut that diagonally, I've cut it into two congruent triangles. Therefore, the area of each one is just going to be half of that. That's where this formula comes from, is just by cutting a rectangle in, or any parallelogram for that matter, in half. Okay. Let's find the area and perimeter of the triangle. Again, let's do perimeter first, like we've done before. I know that it's going to be 34 plus 22 plus, and now I need that third side, which is going to be this one here. Once again, I can do Pythagorean theorem to find it. It looks like this missing side is the hypotenuse of that triangle. So it's 16 squared plus 8 squared equals, and we'll call that c squared. So 16 squared plus 8 squared, I'm going to go ahead and shortcut the calculator, 320 equals c squared. And then take the square root of both sides. Ooh. Square root of 320. That is 17.88. I'm going to write that in. And now I'll just add that in. 34 plus 22 plus 17.88. Forgive me, my computer is doing a lot at one time right now, and it's not registering all these button pushes. When I say it's doing a lot, what I mean is it's running my OneNote program, it's running the recording off of all the different multiple things, the webcam, the tablet. It's pulling all that in, compiling it together, and it's running this calculator, so it's kind of bogged down right now. All right, perimeter is 73.8, and that is feet. Okay, now for area. Area is just base times height. So I need to find 1/2 base times height. So what I need to do is find one side that I also have a perpendicular or an altitude to it. So it looks like the only perpendicular that I have listed here is this angle in the bottom corner, which means that I can use my 16 as the height and then 22 as my base. Remember, obtuse triangles can have exterior altitudes. I lost my phrase for a second. Exterior altitudes. So it's just 1/2 times 16 times 22. 0.5 times 16 times 22 is 176 feet squared. All right, the height of a triangle is 7 inches more than its base. So I'm just going to draw a generic triangle here. It says that the height is 7 more than the base. Well, if I just put a b down there, that means my height is going to be 7 plus b. The area of the triangle is 60 square inches. Find the base and the height. Well, let's see. My area formula is 1/2 base times height. But I know that my height is 7 plus b, so I'm going to substitute that in there. So I've got area equals 1/2 times base, and instead of height, I'm going to write 7 plus base. Now let's go ahead and plug in the 60. So I've got 60 equals 1/2. Well, you know what? Let's go ahead and distribute this 1/2 b. 1/2 b times 7 is 7/2 b, plus 1/2 b times b is 1/2 b squared. Now, I want to go ahead and get rid of that 1/2 all the way through, or the divide by 2. So let's multiply the entire equation by 2. That'll give me 120 equals 7b plus b squared. Now let's get all of our variables onto one side. 0 equals b squared plus 7b minus 120. Okay, so we're going to be looking for numbers that multiply to give me 120 or negative 120 and subtract to give me positive 7. So let's see, 120 is going to factor down. We could do 20 times 6. but that's not going to add to be 7. Let's see, I believe 120 is also divisible by 15. Yep, 8. So it's 15 times 8. And if I make that 15 positive and 8 negative, then sure enough, yep, the positive 15, negative 8 add to be 7 and subtract to be 120. So I've got 0 equals x minus 15, sorry, plus 15 times x minus 8. Now we split that into two equations. X plus 15 equals 0 and x minus 8 equals 0. Gives me x equals negative 15 or x equals positive 8. And anytime that I have a quadratic equation, I want to go ahead and double check both of those to see if they're valid. So if I go in and put x, those should have been b's, excuse me. I changed my variable there. I'm sorry. Those all should have been b's. I made that change right here on accident. Okay. Anyway, I want to go back and double check those to make sure they make sense. So if I go in and plug in a negative 15, well, that's not going to work because we don't, in geometry, in pure Euclidean geometry, we can't have negative sides. So this one is going to be an extraneous solution. However, if I have 8 in here, that's 8. This is 15, and sure enough, that works. So my only answer, or my only possible answer here is that my base equals 8 and my height equals 15. There we go. All right, moving on to trapezoids. Trapezoids have kind of a funky formula. 1/2 times height times base 1 plus base 2. Notice what's going on here. If I rearranged this and I had height times 1/2 times base 1 plus base 2, that this area or this piece of the equation here is the average of the two bases. So what's essentially going on there is I'm taking the mid segment. If you remember mid segments, 1/2 of the two bases, the two midpoints of the sides connected together as parallel, and I am creating or doing just height times 1/2, or height times the mid segment times the average of the two bases. And there's also a reason for that. Again, if I cut this off and cut this off, and then took this and flipped it up, and this and flipped it up, it would make a rectangle. I don't have a nice picture of that. I probably should have included it, and I'm sorry about that. But anyway, find the area of the trapezoid. Notice this one doesn't want perimeter, just area. Find the area of the trapezoid. Area equals 1/2 times height. Let's make that look like an H. Times base 1 plus base 2. Again, whichever one is base 1 or base 2 doesn't matter. 1/2 times height here is 15, times base 1 is 18, plus base 2 is 40. And I can go and type that in the calculator directly like it is. 1/2 times 15 times 18 plus 40, and we get 435 meters squared as my area. Make sure, if you haven't caught this yet, make sure you're putting your units on these things. Areas are always units squared, perimeters are always just units. Find the area of the trapezoid. Now, whenever I go through and do area equals 1/2 height times base 1 plus base 2, well, I know my height is 4. I know that base 1 is 9. I need to find base 2. Now, in order to do that, I'm going to go ahead and draw in this altitude here. Oh, not altitude, this height here. We know it's going to be 4 because it's going to be exactly equal to the other height. Now I've got a right triangle with a hypotenuse of 5 and a leg of 4. Well, that's a Pythagorean triple, 3, 4, 5. So I know this piece is 3. Now, if that's 3, that means I had 6 left over on this side because I have to subtract the 3 out from the 9. Means that that rectangle, it goes across. Base 2 is going to be 6. So area is 1/2 times 4 times 9 plus 6. So 1/2 times 4 times 9 plus 6. And my area equals 30 feet squared. Simple enough. All right. The trapezoid has an area of 210. Find the height. Well, again, we're just going to continue the exact same pattern. Put in the formula, or write down the formula. I keep on running my H's like B's. 1/2 times B1 plus B2. And let's just plug in what we know. Okay, area is 210. 1/2. Height is unknown, so I'll leave it as an H. Base 1 plus base 2, well, base 1 is 20 plus base 2 is 50. And now we just go ahead and solve. 210 equals 1/2 H times 70. Then we're going to make that 1/2 times 70 into a 35. Then divide both sides by 35. 210 divided by is 6. And my unit there is yards. All right, moving on. Rhombuses or kites, these are going to have the exact same area formula, even though they're slightly different shapes. Now, the area formula is diagonal 1 times diagonal 2 divided by 2. 1/2 D1 D2. Now, keep in mind that a rhombus is also a parallelogram. We saw that earlier on example 2, I believe. So you could use either formula for it. So you can use base times height, or you can use 1/2 D1 D2. Kites, our only formula is 1/2 diagonal 1 times diagonal 2. So let's see, find the area of the rhombus. Well, if these two are marked as the same, so that's going to be 7. This one's going to be 9. So it looks like diagonal 1 is 9 plus 9 is 18. Diagonal 2 is 7 plus 7, which is 14. Again, don't get caught up on which one's D1, D2. Doesn't matter. So area equals 1/2 D1 times D2. 1/2 times 18 times 14. So I'm just going to go ahead and do 9 times 14. 9 comes to 1/2 times 18. 126 inches squared. All right. Last example. One diagonal of a rhombus is half as long as the other diagonal. So I'm just going to go ahead and say this. Diagonal 1 is going to equal 1/2 of diagonal 2. Okay, so if the area of the rhombus is 64, well, let's see. 64 is equal to, well, you know what? Let me write the entire formula out. Area equals 1/2 D1 D2. Now let's plug in what we know. Area is 64 equals 1/2 diagonal. Now we said that diagonal 1 was 1/2 diagonal 2. So in this diagonal 1 position, I'm going to go ahead and circle that with orange. In this diagonal 1 position, I'm going to go ahead and write 1/2 D2 because I performed that substitution. And then times D2. Now let's go ahead and combine everything together. 1/2 times 1/2 is 1/4. D2 times D2 is D2 squared. Now, I really harped on this earlier in the year, talking about the difference between a squared versus a subscript. In this case, D1, D2, those 1s and 2s are written down low at the bottom. Squared is written up top, so you gotta keep track of this. This 2 down here is an identifier. It's saying it's the second diagonal. The 2 up top, this one up here, is saying that that is a exponent, or it is multiplied by itself. Now, to get rid of the 1/4, we're going to multiply both sides by 4. So 64 times 4 is 256. equals D2 squared. Take the square to both sides, and I think that was 16. I know I've already done that today, but my memory is going away. Yep, it was 16. So diagonal 2 is equal to 16. Now, we want to know the length of both diagonals. So I know D2 equals 16, and over here I can see that D1 is 1/2 of that, so it's just going to be 8. And it gave me earlier my units were square inches, so these are both inches. So, sorry, let you look at that for a second. Well, there we go. There's that summary. Remember parallelograms? Any type of parallelogram, area is just base times height. Triangles, 1/2 base times height. Trapezoids, 1/2 times height times B1 plus B2. And then our rhombuses and our kites, 1/2 times diagonal 1 times diagonal 2. So that's it for our area of our, what was it? Parallelograms, triangles, trapezoids, rhombuses, and kites. I know that was a lot of shapes, and we threw a lot in there together, but you know what? We did all those, a lot of those back in middle school and in elementary school, so no big deal. Anyway, that's about it. Yeah, I got nothing else for you. Stay safe, stay healthy, stay patriotic.